The RC phase shift oscillator is built up out of our typical voltage divider biasing in order to bias the transistor, but as a feedback circuit it has a collector feedback biasing that controls the bias on the transistor. The RC phase shift oscillator is one of the few oscillators that does not use an inductor capacitor combination to obtain frequency. It does that, however, through a phase shifting capability that the RC coupling has. If we look at this configuration, when we connect the transistor onto the base voltage divider biasing, the transistor is going to activate. That is going to allow a feedback signal to be fed through RC, C1 and R1. So our first shift will occur across C1 and R1. Now, thinking back to RLC circuits, when we've got a series RLC circuit or a series RC circuit, the resistor is going to develop a voltage on the horizontal and the capacitor is going to develop a voltage on the series. The result is going to be that. Now, looking at this combination over here, we can see that R2 and C2 is connected in parallel with R1, which means VR1 is the supply value that I am connecting onto there. Now, with R1, C1, R2, C2 and R3, C3, the exact same is going to be applicable, where I'm going to have VR2 over there and VC2 over there. Okay. The third branch is connected in parallel with R2. So R2, or that voltage, will create my voltage for my third combination. So we can see that we get a near 180 degree phase shift that occurs between the voltage I'm supplying to the circuit and the voltage that actually eventually was received by the transistor. The result is that as this voltage increases, this voltage is going to cause a decreasing voltage on the output. To calculate the resonant frequency of this circuit, the formula that we obtain, resonant frequency equals 1 divided by 2 times pi times the value of R. Now when we're talking about R, it's the values of R1, 2 and 3. They all three have the same value. And C, they all have the same value. C refers to C1, 2 and 3. And then I multiply it by the square root of the number of components that generate my RC phase shift. Typically we use 6 components, 3 resistors and 3 capacitors, to obtain a 180 degree phase shift for the biasing of the transistor. Signal that's generated is a normal sine wave.